This is George Popovic, and in this video I want to talk about asynchronous processing and the Java messaging service. Since JMS is a wide topic, I decided to divide this video into parts. In the first part I will talk about some theoretical concepts I think are important, and also I will create a practical example. For that I will use my NetBeans IDE and the Glassfish 3.1 application server. To start this theoretical review, I would like to first mention the request processing techniques. There are two request processing techniques. One is synchronous and the other is asynchronous. The difference between these techniques is that with the synchronous, both client and server needs to wait for each other until the processing finish. While with asynchronous, there is no waiting for the processing to take place. This gives an advantage to asynchronous on such way that there is less server time being expended and other tasks can be performed at the same time. So a slightly performance increase will be expected. The actors in a JMS system are basically four. One is the message itself. The message is just an envelope with some delivery instructions and some data. Actually, that data can be not just strings. That data can be bytes, so we can send files through the JMS. Then we have the producers, which are those who send who actually produce messages, and the consumers, which are the, let's say, final endpoints that do the processing of that message. Then the message destination is the concept that makes the whole thing asynchronous. So producers send messages to a destination, and consumers read those messages from the destination whenever they have time, because we are working in an asynchronous environment. So the types of destinations, just to mention that there are two important destinations the two JMS offers. One is the queue and the other is the topic. The difference is the approach. Queue uses a point-to-point, which means that only one consumer at a time can read or consume that message. Other consumers will not be able to consume that message if it is already being consumed by another consumer. And the topic, because works in a public subscribe, all subscribed consumers, also consumers that are subscribed to that topic, can consume one same message. So this was a little bit the most important things I think we need to discuss on JMS before starting. And now let's go and have a look at the practical example. Here I will open my NetBeans IDE, and in the services tab I will find my server, and I will start the admin console. My first task will be to configure the Java messaging service. Actually, we are going to see how this is being done. So the first thing is to configure the destination. Here find the JMS resources on the left and click on destination resources. Click on new and give it a JNDI name. You know, the JNDI name is the name that your resource will have in the JNDI registry. So say George's queue, I'm going to call it, and now the real name of it, the physical destination name of the resource, let's call it George queue, and say that this is a queue. So you select this resource type queue. If you want, you can give a description. I'm going to say just here that the destination is the place where producers send messages, and also the place from where consumers read messages. Click on OK, and our destination is created. Now we need a connection factory. The connection factory is something I didn't mention in the theoretical explanation, but I will do it now. It is a service that will create for us the connection object, that will give us access to the JMS service. So in the same way, we will give it a JNDI name to the pool factory. A pool is needed because there can be many connections, so pool is needed. George's Q. I'm going to call it George's Q pool factory. I'm going to select Q connection factory as resource type, and this in description I will give it a description just to explain that this is the service that will create the object, the connection object, so we can access the JMS, or actually the JMS destination. Click on OK, and now all what regards this configuration is done. And I'm going to start my example, the programmatic, the programming, and I'm going to create a project. So I'm going to create a project, and I'm going to create an enterprise application. I'm going to call it, let's call it George's JMS demo. I will click on next. I'm not going to enable context and dependency injection. I'm going to create both modules automatically. Yeah, I think that would be a good idea. I'm going to click on finish. Don't get confused with the option enable context and dependency injection, because context and dependency injection is different than dependency injection. We will use dependency injection, but not context and dependency injection. Anyway, the project is being created, and so here it is. To start our project, I think the important thing would be to, let's say, create a message producer, a message producer, which is the part of the program which will send messages to the destination. So for that, on our EGV module, we will create a new session bean. I'm going to create a stateless session bean with a local interface, and I'm going to call it producer session bean. Let's call it like this. Package session beans. Let's say SB. Finish. I'm going to erase these comments. And now the easiest way to send a message to that destination is if you are using NetBeans, you can just right click, say insert code, and here find send JMS message. Now here are the configurations needed. We will use server destination, and we will select our destination. Georges, you see the JNDI name, and we will give the name of the connection factory, which will create the connection object for us. So for that, let's go back to the application server for a second and find here connection factories. Okay, this was the name. This was the name of my connection factory. Go back to the IDE and place it there. For the server locator strategy, we don't need anything special. We just generate inline lookup code and say OK. And if you see here, automatically NetBeans will give us all that we need for accessing the JMS service. So as you see, there is the queue, the connection factory, injected via dependency injection, and then a message, actually, so not a message, sorry, a method, a helping method, which will be the one who will send actually the message to the queue. So let's use these methods and to send a message. I'm going to just here below, let's say public void send message to queue, and since from the web module we can get some string, some message, we are going to call the method send message to queue and pass the message. This way we will send the message to the queue. I'm going to add the throws declaration, so the exception will not be handled by this method. As you see, it's very simple. I'm not going to go in detail through what each of these methods do, but I already explained it in the theoretical part, how they create the connection and how they produce the message. So as you see, you can see there are classes such as message producer to produce the message and so on. Anyway, this will be the consumer part, the producer part. Now we'll need to create some consuming. So this one is going to send the message, and now somebody needs to consume it. For this, we need to create a message-driven bean. I'm going to call it consumer MDB. MDBs can be the name of the package, and the project, sorry, the server destinations. Here I will give George's queue. So he needs to access the destination to read the message. Here we select the destination and click on finish. Automatically the message driven bean will be created. It is important to highlight that here we have the message listener, which is the interface they need to implement all message driven beans, and then by implementing this message they will have to implement this interface. They have to implement the own message method. Also notice these annotations on top that are some extra data needed, for example for the acknowledge mode, which I'm not going to discuss now, and the destination type that says that it is a queue. And that's pretty much everything about creating the consumer. Now we are going to do some, let's say, real life type of task where I will take that message and transform it to a text message. So message, let's say it's above in the hierarchy, but we need to transform it to a text message. This text message, then we will loop that text message many times to prove that we are working asynchronously. You will see. We are going to cast to text message and message. That's it. Now just create a loop for int I equals to 0, I less than 10, I plus plus, Shift F. Here I will just perform my SOP, system out print line I plus message dot get text message dot get text. I will run this with try catch. I cannot throw because on message it does not declare the throws. I will to make some some delay, so we can, maybe in real life you will not do this, but I'm going to do it to prove asynchronous communication. So I'm going to create a little slip dot let's say 1000, this 1 second, and let's just change this to exception so we can get any exception. Thread dot slip, slip. What I want to do here is just do some processing with the message we wrote from the destination, and do some waiting before each of those processing iterations, because I want later to prove how another method can be called while this one is being processed. So there is asynchronous. Neither the client side and the server side are waiting for each other. So that is the final goal of this example. For that, now I'm going to go to my web module. I'm going to close this and open the web module. I will need to create first a page, a JSF page, because I'm using JSF. I'm going to just do a quick check here to see if I wanted to check in the properties, and I forgot to enable the JSF framework. I'm going to do it now. Just click on Java Server Faces. Yeah, that's it. Or we can use the register libraries 2.1 and click on OK. This will enable JSF in our project. I forgot to do that at the beginning. It's not a problem. We can do it anytime. Add and remove the frameworks. Anyway, So as you see, it works. JSF is working, and now let's get started with the user interface. I'm going to go to the index HTML, and here I'm going to create a simple form, form. In that form, I'm going to create two buttons, command button, one, and command button 2, action. I will give the name of the method later, action, and say value, asynchronous value, synchronous. So one of these will trigger asynchronous processing, one of these will trigger synchronous processing. Create a message driven bin, manage bin for which, let's call it controller, because we are controlling the user interface. Manage bins, and request the scope is fine, say finish, and create two methods. Public string synchronous process, return null, and the synchronous process will just print something. Synchronous process, and then an asynchronous process. I'm going to copy and paste so I don't asynchronous process, which will use the JMS. For doing so, I will inject the EGV that give us access to the JMS. Insert call enterprise bin. Here I will find our producer, say OK. As you see, because we are using a local interface view, the name of the interface is used, and I will say procedure as producer SB dot and call the name of the method, but I forgot to extract it to the interface. Just I'm going to do that quickly. Send message to queue. Just copy the declaration of the method, sorry. And in the EGV module, here on the interface, just add it. Click on OK, and that's it. Now our controller should have access to the methods defined on the interface. Well, it takes a little bit of time. It is deploying. Let's give it a second. Here is send message to queue, and let's say some message. We are going to keep simple things. I'm not going to take that input from the user interface, since this tutorial is not meant to show JSF, just JMS. Surround with try catch. Now we are almost done, and we should go back now to our user interface, and here we are going to call those methods. So for asynchronous communication, we are going to call the controller dot asynchronous process, and for the synchronous communication we are going to call controller dot synchronous process. Let's run this application and see what happens. So here it is. We clicked, I just clicked on asynchronous, and if you see here, every second there is a process going on. I'm going to click on synchronous. Let's check the console. See how the synchronous process perfectly was performed without the need of waiting for the previous process to end. So this is how we can prove the advantage of asynchronous communication. So let's again click on synchronous. Again, a synchronous process was performed while asynchronous was doing some other task. If you see, there is a huge advantage on this type of processing, and there is a big overall performance increase if we use asynchronous communication. And it can be used in many different scenarios. So I think this was the first part of my video on the JMS. In the second part I will talk about the topics, and also I will talk about what is message acknowledgement and why it's so important. So I hope you found this video interesting, and see you next time. Thank you very much.